Good morning, everyone. In the last class, we have seen about like few other optimization algorithm and its intelligent nature. And today, we are going to see about how to relate this optimization technique with your engineering problems. So, as we have seen in the previous classes, like intelligent nature, there might be so in every optimization technique, if you are taking any optimization technique, there might be a certain objective function or goal function. Okay, objective function or goal function or aim, something, everything is same. Okay, there might be some objective function or goal function subject to certain constraints. The constraints or limitations or limits, whatever it might be. Okay, so every problem have its own objective function and as well as the constraints. Okay, say for example, students optimization. If you take the objective of a student. Okay, objective of a student, what is the major objective of a student? To complete all the subject, to complete the all the subject in very good marks. Okay, very good marks. So what is your general constraints might be, you have to study for a certain period of time. You have to study for certain period of time. So by that time, you need to get more marks in the exam. Like one day before only you need to study. Okay, so one day before only you need to study, and but you need to get more marks from that for that particular exam. Okay, like very few hours. Some students might be studying very few hours. Say for example, only 5 hours, 0 to 5 hours. Okay, the minimum time may be it might be varied from 1 hour to maximum of 5 hours only. Okay, so that might be their constraint. So what is their objective? Their objective, some students objective to get pass. Some students, their objective is to get very more marks. Okay, more marks in the exam, like 100% of the marks. Out of 100%, they need to get minimum above 95%. 95%, that is their objective function. But how long they will study now? They might be studying for more time. Might be they might be studying for certain period of time, like 1 day or 2 day, or weekly 1 day, or daily 2 hours, 3 hours they will be spending. So that is their constraints. Okay, so if you take any engineering problem. Okay, this is our student objective. So say for example, holidays are coming nearer. Okay, so what might be our objective function? Our objective function is to enjoy our holidays. Enjoy our holidays might be 4 days or 5 days, might be a week. So our main objective function is to enjoy our holidays. So what is our constraints? The constraint period is given. Say for example, 1 day to the maximum of 5 days. 1 day to the maximum of 5 days. So in that time, what we need to do is we need to enjoy. We need to enjoy our holidays. We need to enjoy our holidays. And also, say for example, if you are planning for a holiday trip, so what is our major objective function? To ultimate aim is to enjoy our the whole holiday trip. So what are the constraints? Is time constraints or day constraints. So 3 days we are going for a holiday trip. And one more constraint is our cost constraints. Okay, so we need to spend from some 2,000 rupees to the maximum of 5,000 rupees. So within this amount only we need to spend our money, and we need to maximize our enjoyment. We need to maximize our enjoyment within the with this much amount of money, 2,000 to 5,000 rupees, like that. Then maximize our enjoyment. Then maximize our we need to visit more places. Okay, more places within that 3 days. We need to visit more places. Minimum in a day we need to visit some 3 to 4 places in a day. Like that, will be planned. Okay, so even if you are planning for a industrial visits and all, we'll plan 1 day for industrial visit and another 2 days for our enjoyment. We go to nearby tourist spots and we need to visit. And the constraints is we need to spend very minimum amount of money. So that is our constraints. And like any thing you take, a company, say for example a company manufacturing a certain pen, okay, pen manufacturing company. So what is their objective? They want to increase their profit. They want to increase their profit this year, okay. Compared to the previous year, they want to increase their profit. Then what is their constraints? They need to do within a very short period of time, okay, in the seasonal time, in the school time itself, okay. So that in between 1 month, if you take like a summer vacation or winter vacation, that pen sales will be very very less, okay. So but within the season, they will be having one season, no, from January to some April, okay. Then again from June to again December, like that they will be having some season time. So within that specific period of time, they need to increase their profit and they need to succeed in the market. They need to come up with a less cost, okay. That also sometimes might be the objective, less cost and less and sometimes so the objective might be varying, like minimizing or maximizing. Sometimes they need to minimize their product cost, maximize their profit, okay. So objective, you see, maximize their profit, minimize their product cost, okay. Say for example, some few students, they want to get maximum marks. Out of 100 marks, they need to get above 95, okay, above 95 marks, or maybe 100 also, centum also sometimes. But when compared to the rank, when coming to the rank, okay, so they need to get first rank, okay. In that case, minimum rank is the maximum privilege, okay. They need to get first rank, okay. Then they need to get maximum marks, okay, maximum marks. As I said, profit has to be maximized and the product cost they need to minimize, so that they will be succeed in the market. So time, minimum time. So whenever they are coming up with a product, they need to release very soon, okay. Otherwise the competitor company will release, okay. That is what happening in the mobile phone, smartphone companies. So what they are doing is, if they are planning for a new product to be launched in the, say for example, in the next year 2023, next year. So what they will do, they will now itself they will release the specification, okay, specification. So these are the specification we are going to release in the month of the December 2022 or January 2023. Okay, so approximate cost is like 15,000. That is the more featured phone, okay. So they have to compare, first of all they have to compare all the models, then they have to come up with more features, okay. So immediately, okay, so in that specified time only they need to release, okay. So from January to December they will be having some 12 months of time, okay, 12 months of time. So within that, maybe before that also it is more welcome, but they need to release in the specified time. So what other competitor companies will do, they will also copy all the specification. They will release in the month of May or June itself, okay. If they release in the month of May or June, then automatically that whatever the company they said no, they will be going to launch. So entire thing goes wrong. Okay, so as soon as possible, even though they are telling the specification within 1 month, okay, within 1 month, they should not wait for 10 months like that. Within 1 month, that is the constraints. Okay, so that is the constraints within the less period of time, maybe 1 day to 30 days, okay, or 1 day to 60 days, like that, within less period of time and with the more features. Okay, more feature is the objective function, more feature and with the less cost. Okay, cost should be very less and the specification might be more. Okay, so it depends on the the product. Okay, product or whatever the thing you are choosing. Okay, sometimes our objective might be maximizing, sometimes our objective function might be minimizing. Okay, coming to cost, if you want to design a product, coming to cost, we need to minimize our the product cost. We need to minimize our product cost. Coming to say for example enjoyment, we need to maximize the profits of the company, like that in that scenario we need to maximize the objective. Okay, it depends on the problem we can say specifically we can say like that is called the problem. So whatever the problem we are taking into the account, engineering problems, or even though it is engineering problems, or it involved in some economics problem, or whatever the problem we are taking into the account. So it depends on the objective. And also constraint. Sometimes time constraint, sometimes cost constraint. Okay, like that it might be varying. Sometimes workers, so in the company they will be fixing some target. So this many workers only have to work for this product development. Only 500 employees only will be deputed for this product development. Only this many employees only deputed for this product development. Okay, so they are releasing many models now in the same company itself. In smartphone company itself, they are releasing many models. So they will be deputing so this much of employees for manufacturing this many products. That is the constraints. Okay, so the employees they have to start from 100 employees to the maximum of 500 employees, or minimum of 300 employees to maximum of 1000 employees have to work for that particular project to complete that particular task. Okay, so this might be the optimization problem. So every optimization problem has its own objective function and as well as the constraints or limitations. Okay, objective function subject to constraints. Okay, if we are going to discuss with the engineering problems, that is electrical engineering problems, their objective function also might be varying. Sometimes we need to maximize our transmission line, maximize our transmission lines, kilometers or distance. Okay, so what is our objective? To get a reliable power to the end user consumers. Okay, whether the consumers might be very nearer, also within the range of 10 kilometers also. Sometimes some consumers might be locating in the some 30 kilometers apart. Okay, 30 kilometers apart. Okay, but we need to provide the supply to that particular consumers. Okay, so what is our objective function? In that scenario, we need to give the electrical supply to end user consumers, whether they distance not at all matters. But what is our constraints? Within some specific stipulated time, okay, specific period of time, we need to install that transmission lines and distribution lines to that particular places. Okay, and also cost effective. It should be cost effective. Okay, sometimes we can run the transmission lines towers for 30 kilometers. Sometimes due to the cost effective, what we can do is we can install there itself, because the load is very less. No, five consumers are there. So for that 5 consumers, we can install their solar PV panel. Okay, with the one battery backup, with a small battery backup solar PV panel. Because say for example in the remote places, they might be utilizing that electricity supply only after 5 o'clock or 6 o'clock to the maximum of morning 6 o'clock. So only 12 hours they need to give the supply. So what they can do is they can install a small solar PV unit, or sometimes if the wind velocity is more in that particular place, they can install a a small mini wind turbine unit, okay, mini turbine unit of like a 0.25 megawatt or 0.2 megawatt, like that mini turbine, okay, mini turbine they can install, and they can feed the suppliers, like local suppliers, okay. That also okay. And if they want to install a transmission line, that also okay. But our ultimate aim is to minimize the total cost, minimize the total installation cost, or from their substation to that, we need to minimize the cost, okay. So we have to compare the cost, okay. For transmission line, it is costing around this many rupees. For installing a PV plant, or for installing a wind turbine plant, it is costing around this much cost, okay. So we have to compare. So minimum cost we have to go for. It has to solve the purpose, and as well as our constraint also should be met out. For 5 consumers alone, if you are running a transmission towers and a transmission line for some 25 kilometers or 30 kilometers, okay, in hilly areas or some other regions, okay, it is very costly, okay. For installing transmission towers in the hilly areas, it is not at all a easy task. In the plains, we can easily install, okay, even easily install. If the consumers are more, we can easily install. But here the problem is different, and objective should be satisfied. But the constraints also very, very important. Cost, okay. For installing 30 kilometers, we are spending some lakhs, or even crore also, okay. But for installing a PV plant, we can install within some lakhs, okay, within few lakhs, okay. So that so we have to intelligently, we have to think, okay. So that's why we are the engineers. So that is only good engineer, okay. So for 5 consumers, if we install 30 kilometers transmission towers and the transmission line, everything, so we have to spend more amount, okay. So the ultimate loser is the like power generation companies or power distribution companies only, okay. But if we install intelligently, if we think, and if we install a PV plant, or if we install a wind turbine unit, then ultimately our cost involved in that particular thing will be reduced, okay. So that also we have to think intelligently to solve any purpose, okay. Not only in the problems might be differ, okay. I have told a simple example, the engineering problems, the day by day the problem will arise, okay. Day by day the problem will arise. So we need to think in a like a optimized way, in an optimized way, where the cost will be reduced, and also the purpose also have to be solved. As I said in the yesterday's class, okay. Say for example, if you need to design a small circuit, okay, small circuit, say for example filter circuit for your earphones, okay, filter circuit for your earphones, okay. So filter circuit you are designing, you're asked to, you are working in future you are working in some electronic companies, top electronic companies, like Realme, or your Redmi, then many companies are there, Nokia, Samsung, like that. So then boAt. These are some of the earphone manufacturer leading in the market, okay. So now you want to you have given with the task of reducing the like noises in the like your earphones and the receivers, okay. So what you are doing is you have designed a certain like filter model, okay. So the consumers, the customer is coming to you and asking you to design. You have also designed. Say for example, that the task is being given to 5 different people, okay. 5 different people or 2 different people, say for example 2 different people. So you have designed a circuit. You have designed a circuit with some the size of that circuit was some 1 centimeter that is coming, that filter, 1 centimeter by 1 centimeter, you have designed a small filter design. Whereas next task is given to a friend. He also he or she also designed a small filter design of like very 0.2 centimeter. Okay, 0.2 centimeter. Yourself cost is for designing that your filter, that cost is it is coming around say for example 100 rupees. Okay, whereas your friend 0.2 centimeter only, your friend designed the same, it is also doing the same task, it is coming around only 40 rupees. Okay, 40 rupees, very 0.2 centimeter. Then yours is 1 centimeter, 1 by 1 centimeter. Your friend's is 0.2 into 0.2 centimeter. Okay, that is very 2 mm. Okay, 2 mm only your that filter design is. Yours is 10 mm, 10 mm the sizes. So which one the customer will select? Definitely the filter design with very sleek design. Okay, design is compact and it also does the job. And you are claiming like, yeah, my filter design is coming around and 99.8% efficiency. Okay, you are claiming like your filter design is coming on 99.8% efficiency, whereas your friend is claiming like 99.5% efficiency. Filter design is 99.5% efficiency. You are claiming like 99.8% efficiency. Okay, 99.8% efficiency. Your friend is claiming like 99.5% efficiency. Okay, the difference is only 0.3%. 0.3% only the filter design efficiency is getting differed. But this also does the job, but the cost is only 40 rupees. Yours cost is 100 rupees, but yours efficiency is good. But even though your size is somewhat big, because if you are calculating with the efficiency and with the cost and with the size, okay, you need to go for like a LC filter, no? So that combination of LC filter, the capacitor, you need to increase the size of the capacitor, and in that scenario the cost of the capacitor also getting increased. Okay, and the size also getting increased, but efficiency you're getting. Okay, so your friend also claim, so definitely they might be choosing that only because 40 rupees, and you are claiming that lifetime of that filter design is approximately this many hours, say for example some 10,000 hours. Your friend is claiming like lifetime is 9,500 hours. Even though 500 hours is getting deferred, but that is solving the purpose, and also cost is less, and the size also compact. Okay, so the company might be choosing that design only. The consumer might be choosing that design only. So why? Because it is solving the purpose, and optimized design, optimized cost, everything getting optimized. Even though efficiency is somewhat different, somewhat different. Number of operating hours also somewhat different. So as an engineer, you have to think like in an optimized way. As an engineer, always you have to think in an optimized way. Whatever the product, whatever the thing you're designing, getting designed, so you have to come up with the optimized way. You can compromise with some certain efficiency when comparison, when compare, like it should be very mirror means it is okay. So efficiency is very less means we can't compromise. Even though you have come up with a durable design and whatever it might be, we can't. If the efficiency is somewhat compromising, say for example 0.3% only compromising in our example, sometimes it is compromising 20%, 30%, then even though your design is compact, that is of no use. So as an engineer, you have to become a smart engineer, intelligent engineer, like optimized engineer. You should be. You should be. Then only you will be succeed in your market, and your coming up with a smart startup company. You're designing certain products, say for example led bulbs you're designing. Okay, so whereas in the market many competitors are there, Philips, Crompton, Wipro, like many competitor companies, they are designing the LED bulbs. Okay, in that scenario they are coming up with a very less cost. Okay, some 18 watts, 9 watts, okay, 6 watts, okay, then 2 watts, 1 watt LED bulbs and all that, 5 watts. So they are coming up with a very less cost. Okay, and also a number of operating hours also. So if you are coming with a startup company of LED bulb manufacturing company, so you have to compare all these things, number of hours, then star rating, okay, B star rating, okay, Bureau of Energy Efficiency star ratings, then the quality, then cost is very very important thing. So this three four constraints are different. Okay, they will not look on to all those 3 4 constraints. Okay, maybe star rating, they sometimes they might be seeing. Okay, so star rating sometimes might be seeing, or sometimes they might be seeing but ultimately they might be seeing the cost constraint only. They might be this constraints, they sometimes they might be compromising, but cost. Okay, so they are coming up with the 18 watts bulb. Some companies claiming like 250 rupees. Philips is claiming like 250 rupees. So Crompton is claiming like 270 rupees. So some other companies claiming like Cisco, that LED company is claiming like 240 rupees. So if you are coming up with a new LED, same 18 watts bulb, so if you claim with 200 rupees, then definitely you will be succeed in the market. Okay, you will be leader in that particular market, and your product sales might be like anything. Okay, so no one will come to, because 40 rupees, 50 rupees, your LED bulb is less. You are also coming up with a number of operating hours very nearer to that, and the cost also you are coming up, and the star rating also you are coming up with more than that also. So definitely like this only you have to compare, and you have to come up with the optimize. And say for example you're reducing the size, of the LED bulb, like a very sleek design, but the wattage is more, the power is also more, luminous power also more. Okay, so that also they are giving. So you are also given come up with a new design, whereas the like light luminous of that particular room might be very very more. So definitely you will be succeed in the market. So while design, not only I've said a simple example. So every product, whatever you have design, you have to come up with a optimized model. Okay, so then only you will be succeed in that particular market.